Okay, this is lesson 6.2, and in 6.2 we're going to solve triangles using the properties of similar triangles. So first example says, given that triangle ABC is similar to triangle DEF, find the measure of C and the length of DE. Well, since we have similar triangles, we can match up the corresponding sides or corresponding angles with each other. So angle A should match angle D because it's the first letter in each triangle name. So we've got angle A and angle D. So angle D is 28 degrees. Angle B should be the same as angle E. Angle B is 121. So angle E should also be 121. And lastly, angle C, which we don't know, should be the same as angle F because it's the last letter. Angle F is 31, so that means angle C is 31 degrees. So there we go. We just solved the first part by matching up the sides. To find lengths, we use the idea that the proportions should be equal. What's that mean? Well, that means that if we compare similar sides, like AB to DE, AB to DE, if we divide those, we should get the same as BC to EF. BC to EF. And finally, AC and DF are similar. So AC to DF. All those ratios should be the same. Now we don't know all the sides, but we can fill in the ones we do know. We know AB is 12.1. We don't know DE. We don't know BC. We don't know EF. We do know AC. And we do know DF. So now we have, well, an equation that has a bunch of stuff filled in. One pair we know nothing about, BC, EF, and we're not asked to find BC or EF, we're asked to find DE. So we want to find, let me get a highlighter here. We want to find DE, so we need to use that fraction. And we don't know anything about this fraction, so we can cross it off. We do know everything about this fraction. So let's rewrite it. 12.1 over DE equals 20.1 over 16.1. All right, so now we're going to solve this equation for DE. And here's how we do it. The solving steps are always the same. We start with bottoms up and across. When we bring the bottoms up and across, we multiply. So we get 20.1 times DE, and we get 12.1 times 16.1. We can actually do the multiplication. I need a calculator. 12.1 times 16.1 is 194.81. Put that over here. And we got 20.1 times DE. So now if we want to get DE by itself, we have to divide away the 20.1. And that'll leave us with DE by itself. So we got 194.81 divided by 20.1. And we end up with, we'll round, 9.7. And that is how we use similar triangles. So we write out all the pairs, fill in the ones we know, cross out the one we don't know anything about, bottoms up and multiply, and then divide away what's in front of the letter. So if we were to write these as steps. Number 1, Write pairs of similar sides as ratios. And that's our step 1. Step 2, fill in all known side lengths. That was here. 3, cross off unknown pair. That was also here. Step 4, cross multiply. That's step 4. Step 5, divide away number in front of unknown side. That's step 5. So there we go. Steps 1, 2, 3, 4, 5, and here they are. Step 5, step 4, step 1, step 2, step 3. Sorry, I'll move that over. Okay, we're going to use these same steps to do 2 more examples. Find the length of FG to the nearest tenth of a unit. So we're assuming that FGJ triangle is similar to IHJ triangle. Well, we need to check this out first because we're not necessarily sure. We have a pair of opposite angles, so those are in fact 43. So that's good. We got a pair of right angles. Awesome. And that means that F and I we don't have a number for. But since all of the angles in a triangle need to add to 180, we can use angle F must be 180 degrees minus the 2 angles we already know. So we know one's 90, we know the other's 43. So that leaves us with 47 degrees for F. So that means that this one's 47 degrees because it's the same or similar triangle. So now we can write our similarity statement. Let's name our triangles. Triangle, we got FGJ and HIJ. Let's start with the small one. HIJ. So that triangle is going to be similar to triangle. And now we got to label them in the same order. H is the 90, so we start with the 90. G, 47 is I, so we use the 47. F, and the last side is J. Perfect. G, F, J. So now we have to write our similar side pairs. And to do that, we look at 2 angles and we pick the sides that are between the 2 angles. So let's start with FJ. We got FJ. FJ is between 47 and 43. So between 47 and 43 is IJ. So that's our first pair. Our next pair is between 47 and 90. And that is, so this is the letter I. I to H. Oh, I made a mistake. So the key to writing our pairs is that if we started with the big triangle on top, the big triangle always has to be on top. So I did F to J first. So now my first side also has to be from this triangle. So I did F to J, and that was similar to I to J. So now I'm going to start with the big triangle again. I'm going to do J to G. And J to G is from 43 to 90, so from 43 to 90 would be J to H. And our last pair would be from G to F. And that's from 90 to 47. 90 to 47 is H to I. All right, now we got our pairs. So now that we got our pairs, we can fill in the sides we know. F to J is 18.9. I to J is 6.3. J to G is unknown. J to H is also unknown. I guess we're not going to use that triangle, or those two sides. G to F, also we don't know. And H to I, we do know that one, 4.3. So hopefully we're solving for GF, and we are. FG is the same as GF. That is indeed what we're solving for. FG, GF. So we are good to go. So we can rewrite now. We got 18.9 over 6.3 equals GF over 4.3. So let's start with the bottoms up multiplication. We got 4.3 times 18.9, and we've got 6.3 times GF. And our last step is to divide away what's in front of the letter. We'll divide away the 6.3. I'm going to do it before multiplying, which is okay. And that should leave us with GF. So let's do a little bit of math. We got 4.3 times 18.9 equals, and we're going to divide by 6.3. We get 12.9. And that's what side GF is. Oh, couldn't see that. All right, one more example. Example 3, use parallel lines and similar triangles to find missing measures. So in the diagram, DE is parallel to AC. Find the length of AC. So what's neat about parallel lines to make triangles is that it might not be clear, but we do have two triangles in this question. I'm going to draw them. We've got a big triangle, ABC. And we've got a smaller triangle, DBE. And some of these side lengths we know. We know D to B is 48. We know D to E is 36. And A to B is 12 here and 48 here. Together, that would make 60. So if we want to find the length of AC, we're looking to find this side length. And it's nice because we have a pair of similar sides, and we have a partially complete pair of similar sides. We don't know anything about BC and BE. So in previous examples, we've been writing out the whole fraction. We might be able to cut that down in this example. Before we move on, though, we have to make sure that these are similar triangles. And because B is shared, B and B are similar. Because D and A, if we highlight those angles, we got one here and one here, and that makes an upside down and backwards letter F. So in the F pattern, angles are equal. So that means D and A are also equal. There's also another F pattern here, E and C. So E and C, and designate with 3, are also similar. So what do we have? Well, we have that triangle ABC is similar to triangle, start with D because we started with A, move to B, E. And now we can write our similar pairs. We've got AB and DB. We've got BC and BE. And we've got AC, keep this big triangle on top, and DE. And we don't know anything about BC and BE, so we don't actually need that one. We can just fill in what we know from the other two. Well, AB is 60. DB is 48. We don't know AC, but we do know DE. And in both previous examples, we've done cross multiply and then divide. In this one though, and the one previous, you don't have to do both those steps, because if the letter you're solving for is on top, you only have to bring this one up and multiply. You can save yourself bringing the 48 up because we're just going to end up dividing it away anyways. So this rearrange would look like this. AC 60 times 36 over 48. And now we've set up this question to solve much more efficiently. Instead of doing a double cross multiplication and then dividing, we can just bring one number up and multiply, and that allows us to isolate for AC. 60 times 36 divided by 48, calculator. 60 times 36 equals, divided by 48 is 45. And we're working in centimeters, so 45 centimeters. And there we have it. All right, that's it for lesson 6.2. Thanks for watching, and I'll see you in 6.3.